So taking a look at number one here, I think the first thing that I would do would be to write the positive pieces in the front and then write the negative pieces in the back like this. So let's see, I put that first in the front and then that one's positive, so I put it there, but instead of 0.75, I just said 3/4, same thing. And then that one there, the negative 2/3 is there. Now for this one here, you see how I turned it from over 4 into 1/4? That's because there was an invisible 1 right there in front of the log. So I said 1/4, and that's how I got that. So now what I would do is I would take all these coefficients and bring them upstairs so that they become exponents like this. So let's see, all of these coefficients have become exponents. Make sure I didn't mess this up. Cool. Now, so we have positives first, negatives in the back. All the coefficients are now powers, which means that we can now finish this problem. So it's going to be one giant log where, since some are positive and some are negative, you know there's going to be a fraction where these pieces from the positives go in the top and these pieces from the negatives are going to be put in the bottom like this. So if you were to say this on an exam, that is 100% perfect. However, I think the answer key, they were a little technical. Instead of writing fraction exponents, they wanted radical expressions like this. So I think they said this instead, but these are the exact same thing. So either one of these is perfect. You don't have to give me both, but that's just how they did it, right? Where that, to turn that into that, what you do is that numerator stays with the big number, but then the denominator becomes the root. So that's how these three in particular went from rational exponent to radical expression. So that takes care of number one. Now for number two, let me rewrite the original expression like this. So instead of writing radical expressions, I wrote them as fraction exponents, which is what we just discussed for number one, right? That's sort of like what we did here. So I decided to write them as rational exponents instead of radicals. Now I think we're ready to break this apart, where we're going to split this up into a bunch of logs, where the numerators will have a positive log, and these pieces from the denominator, they're going to have a negative log, like so. And now the final bit would be to take any of these exponents and to push them to the front as coefficients. This one doesn't have an exponent other than 1. You don't have to do anything with that. So let's take all these powers and push them to the front of their respective terms for our final answer. And so there you are. That is how we condense and expand some of these more complicated looking logarithmic expressions.